record on this computer. Start the timer. Welcome, my name's Jane Creighton. I am presenting on Deep Processing and Meaningful Making, a cognitive exploration of makerspaces and badge systems. First and foremost, makerspaces can be described as places where individuals engage in creative production, utilizing both digital and physical technologies to investigate concepts, acquire technical abilities, and craft innovative products. Makerspaces originated from the maker movement, which was a grassroots endeavor inspired by the principles of John Dewey. The contemporary makerspace is fueled by the emergence of digital technologies such as 3D printers, laser cutters, CNC mills, and plotters. Makerspaces provide a unique opportunity for hands-on learning and creativity, but their effectiveness in promoting deep learning experience requires critical examination, especially when using badges. So we're going to look at this from a cognitive learning lens in makerspaces, and this refers to the process of acquiring knowledge, understanding, and skills through mental processes such as perception, attention, memory, reasoning, and problem solving. It involves actively engaging with information, making connections, and organizing thoughts to construct meaningful learning experiences. Cognitive learning theories emphasize the importance of internal mental processes and how they influence learning outcomes. In makerspace environments, cognitive learning is highly relevant as it underpins the acquisition and application of skills related to design, prototyping, and problem solving. And these are just some of the cognitive learning skills that are hopefully attained through participating. Additionally, peer modeling should be mentioned here as it is another crucial piece. Peer modeling refers to the observation and imitation of behavior, skills, and techniques demonstrated by peers or more experienced individuals. And here's how peer modeling contributes to cognitive learning sciences in makerspaces. So social learning, peers are modeling and leveraging social learning mechanics where individuals learn from observing and interacting with others in their social environment. Also self-efficacy and confidence. Peer modeling influences individuals' self-efficacy and beliefs about their confidence and their ability to succeed in makerspace tasks or challenges. Collaborative learning, they learn to foster collaborative learning environments where participants share knowledge and co-create solutions. And they have a feedback and reflective area of peer modeling, which promotes constructive feedback and sharing observation, insights, and suggestions with their peers. Micro badges and credentials. So what are they? A badge system commonly used in a makerspace and various education settings offer micro credentials as a means of recognizing and validating specific skills and competencies. These systems serve to promote safety, proficiency, and inclusivity within makerspaces by providing a standardized framework for assessing and acknowledging individuals' capabilities. Additionally, badge systems facilitate learning and professional development beyond makerspaces, empowering individuals to showcase their expertise. Examples of these are badges and Canvas. So key cognitive processes involved with learning with badges and makerspaces are attention, memory, problem solving, metacognition, and motivation and goal setting. And additionally, badge systems influence on those in makerspace activities really do help enhance the attention and facilitate that memory formation through that repetitive viewing of the modeling, etc., and promoting problem solving skills additionally. Cognitive theory's approach to making and badges really is rooted in constructivism and situated cognition, and these help emphasize they really help emphasize the real world challenges and connect that to the learners. And they also bring that hands-on experimentation and reflection to the learning. However, the problem is with badges in particular in makerspaces is really that it is a form of extrinsic motivation, and it doesn't always align with the principles of self-regulated learning and intrinsic motivation. And this focus on earning badges to gain access to tools or spaces or machines can shift the focus away from genuine curiosity and exploration and potentially hinder the depth of those learning experiences. So here we look at a case study by Whelan and Moody, and they critique the rise of micro-credentials in higher education, arguing that they reinforce the discourse of employability skills and human capital. And they contend that micro-credentials perpetuate a narrow understanding of learning outcomes and shift the burden of training from employers to individuals. Um, and this is really interesting because the analysis resonates with the discussion on badges and learning, particularly within the context of cognitive learning theories. While micro-credentials and badges offer tangible recognition, they risk oversimplifying learning outcomes and neglecting the deeper cognitive processes involved in skill acquisition. So also looking at this other paper about makerspace badges being implemented and students' perceptions of informal credentialing, I've highlighted 5 reasons why this study on informal credentialing falls short. And really, it's got a limited focus on the learning outcomes, low participation rate and accessibility, lack of clarity on badge value and skill validation, inadequate assessment framework, and they really missed an opportunity to provide makerspace mission fulfillment. They really focused instead on jobs and outcomes and overshadowed the broader learning and cognitive benefits of engaging with makerspace tools and workshops. So we'll be diving into that in this paper. Understanding student engagement with makerspace workshops and badges through cognitive learning lens is really important. We need to look at motivation, goal orientation, perceived value and utility of the student and how that will help them decide if they're going to do it, cognitive load, time investment, feedback, reinforcement, learning preferences and priorities, and barriers to participation are all really important attributes that we need to be looking at. Especially motivation and engagement, and how we need to look at how those badge systems are impacting learners. What's the role of intrinsic and extrinsic motivation in badge learning, and how they play a pivotal role in either including or excluding individuals from participating in those learning conditions. And what if the understanding of intrinsic versus extrinsic motivation is really the key interplay of what we have to understand about how to implement these badges? So learning outcomes and skill development, we need to look at procedural skills, how they use tools and what those procedures are, problem solving abilities. Makerspaces offer those ideal environments for that, but it's tough to teach them how to brainstorm and identify challenges and questions and reiterate through those prototyping and testing. All that incorporates that metacognitive strategy. So they're developing that and kind of reiterating what they're doing and self-regulating what they're learning. And that conceptual understanding beyond the technical skills really need to focus on the principles, the participants of applying their knowledge flexibly across various disciplines and contexts, and all that rooted in collaboration and communication. But that brings us to another case study here, and the case study is by Kerr and Risen, and it's about a badge system called the Maker Access Pass platform, which allows students access to use a makerspace. But in really diving into this data, it was evident that that they were kind of skewing the data, and it demonstrates they had 47,184 total patrons since 2017, with an average of around 15 to 16,000 patrons per year. However, they've only awarded 1,473 safety badges, which is the required badge to be able to use the space or use any of the machines or book a machine. And that is really important because Kerr's claim of 5211 digital badges awarded through the Makerspace Access program platform really is deceiving, because ultimately it's only 1,473 original users, and those additional badges are badges that those 1,473 patrons earned after they earn their safety badge. So that really tells about a very exclusive makerspace here, and that there's a huge discrepancy between the number of badges awarded and the actual patrons visiting this makerspace. So we'll be diving into that. And that also leads us into implications for diversity, equity, inclusion, which we'll touch on accessibility and equity, representation, recognition, mitigating bias and stereotypes, promoting inclusivity and belonging, addressing structural barriers, and collaborating and community engagement are all a little bit at play here in this paper, because when you don't consider DEI with cognitive learning, you leave out a whole bunch of real world applications for the students and opportunities where they would be able to really help build and leverage and cross the structural barriers that may hinder them from participating in some of these programs. Challenges and future directions. We're going to identify challenges and limitations associated with badge-based learning systems and makerspaces, and I'll be discussing potential and future directions for research, practice, and optimizing badge systems for cognitive learning outcomes. Here are my references. Thank you for your time.